of linked list. Linked list is a very important topic. In my opinion, the most important topic of DSA. For a simple reason that, first of all, linked list questions are pretty limited. Okay, so this is one topic in which if you really do the hard work, you can get the gains out of it. If you actually practice all the questions that we have done in the class and you solve the assignment questions yourself, you can't get a very new question in linked list. So in the interview also you might get something which you have already seen before. So that's why this is an important topic because it is doable. All right. So let's do a revision of linked list. I'll go through all the classes from intermediate to advanced. I'll just mention the important things. Okay. Briefly, we'll go through everything that was done. I won't go into solutions or anything. Just go through the revision. If you feel there's a point where you could not understand that topic, go back to the lecture and try to understand it. All right. So okay, so this is what we did. This is how we started linked list. We first talked about arrays and how popular arrays are and what are the advantages in array. Then a bit of disadvantages with static arrays. Then we jumped on to dynamic arrays. What are the advantages, disadvantages of dynamic arrays? Now there was a very interesting thing that we learned that day, that the TC of insertion of a dynamic array is O of 1 amortized. It's not really O of 1. It can have a worst case time complexity of O of n. So go through that part where we try to understand why it is amortized O of 1. And here we also looked at the internal implementation of a dynamic array in a little brief. Then next we understood a bit of disadvantages that dynamic array provides, and there came the intuition of a linked list. Okay. Then we went on to see how a linked list can be implemented by us. We got to know that okay, we need a custom data type. There we saw how to make a class node which can have the data types which can together constitute a node. Okay. And then we tried out a few questions. This is all the theory that is present in linked list. From here on, we just did a lot of questions. Every question was important. I think we started with simple questions first. Given the head, print the size of a linked list, easy traversal, figure out the size, get the answer. Next, now this is a very important point. Here we discussed how to solve problems of linked list. Linked lists are important. They are simple also in my opinion, but they are tricky. There's a process that you have to follow, and the most important part of the process is checking for edge cases. It's very important. The algorithms, the solutions for linked list questions will always be simple, but it's the edge case which can be the deciding factor whether you got the solution accepted or not. So it's very important. Okay. I always prefer that you try to figure out the solution on a pen using a pen paper. Okay, you figure out the exact algorithm, you do a few dry runs, you check for edge cases, and then only you start coding. Okay, now when we even for checking edge cases, there is a set pattern that you can follow. You always check whether your solution is working for an empty linked list when head is pointing to null. Always check when your linked list, if your linked list is of size 1, will your solution work? And obviously there can be some edge cases which are problem specific. Now then we went on to solve a few more questions. Create a linked list with n nodes with data 1 to n. A pretty simple problem. Do go through it, you'll understand it. Then we did this question where we talked about insertion in a linked list. Let's say you want to insert a node at the end of a linked list. How will you do that? You're given the head. Like in all linked list question, you will always be given the head and you have to work your way through it. So insert in the end. You can go through this part. Important. But if you have done a few linked list questions, I think these questions are super simple for you. Then we talked about inserting node at the head of a linked list. I think the earlier question was insert at the end of the linked list. Okay. Now we saw how we can insert at the head of the linked list. Then another type of insertion, insert a node at the kth position. Let's say each node is defined by some position and now you have to insert some value, a new node at this position. How would you do that? This was a very interesting problem because it had a few edge cases that we had to handle to try to understand it. And that was it. This was our intermediate class. Now I'll quickly jump on to our advanced classes. We had 3 classes there, and I think we just did questions, right? So this was the first question. Search for an element k in a given linked list. The head node will be given. Easy, simple traversal. You got the answer. Nothing too complex. Then delete a node. First, we talked about deleting at head. How can that be done? A very simple logic. I think it was just a 3-line code and we were done with it. Then insert at tail. Another different version of the question, where we are deleting the element at tail. This had a few edge cases, so try to understand this problem. I think it was different because it was not just a straightforward traversal with one pointer. We needed a previous pointer too and a current pointer also. We need to traverse using both these pointers and then reach a place where we are deleting the last node. Next, delete the first occurrence of a given element k. Another different version of deletion, just for more practice. Then a supremely important question, very, very important question: reverse a linked list. Why is this important? First of all, it's a good question, asked a lot in interviews. Plus, there are many different questions where reversing just comes in picture. It's a different question of a linked list, but you have to use reversal in some way. So it's very important to remember this solution. Okay, this is not a question which you just solve and forget. Try to somehow retain how you solved this in the first place at all times. We and this was an interesting question too, because we used 3 pointers and then we were traversing those 3 pointers, and at each time we just reversed a link, and that's how we solved it. We discussed a lot. If anyone has any doubts here, do go through this part in the lecture and understand this problem. And then next question, given a linked list, every node has 2 pointers, a next pointer which is as usual, and a random pointer which can point to any other linked list, any other node. Now you have to make a deep clone of this linked list, a brand new set of n nodes which have the same structure. So basically, you are given this linked list. You have to create brand new n nodes which inhibit the same structure. Now, this was a tough problem. There was one solution which was not very tricky. Most of you got it in the class as well, where we used a map as a data structure, and we just stored the position of random pointers in the map. We did that and it helped us solve the entire question. Do go through this whole concept. Many of you were able to figure it out in the class itself, so you'll understand this quickly. The second approach was tricky. It had a very non-intuitive solution. These are some questions, if you're asked in the interview. I don't think this is a good question to ask in an interview, frankly, because either you know it or you don't know it. It's very, very tough to figure this question out in just 20, 25, 30 minutes. But yeah, it had a very interesting solution. How we were doing this, we were first adding nodes in the original linked list only. Then we were pointing, we pointed the random nodes of the new linked list nodes properly, and then we decoupled the linked list. It's a complex solution. I can't complete it in revision. Do go through it. You'll understand it. If possible, try to remember it. This is a question which you should just put it in your notes in front of linked list, and before going to any interview, just go through these questions which are supremely tough to figure out. Then the next class, again we did a bunch of questions. This was a very, very important class because of this concept. Given a linked list, find the middle element of a linked list. Now it has a very simple solution. Anyone can think of it, that okay, first I'll find the size and then I'll go to the middle, and that is my middle node. But there was a second approach, using slow and fast pointer. Now this was very important because again, this question, it's very interesting how we use slow and fast pointers to get the middle point, but there are many different questions which use the same concept of slow and fast. So it has a lot of different questions. So we understood how we can use slow and fast to get the middle point using this car example, and then we solved it. We checked out 2 cases. If there is an odd length linked list, how slow and fast work there. Slow and fast basically mean we have there my slow pointer moves one step at a time, my fast pointer moves two nodes at a time. That's it. And then we got to understand how we can find the middle node in an odd linked list, in an even linked list. And then we went on to check out the pseudocode. Now, the second question that we did that day, find if a cycle exists in a linked list. Again, we used the concept of, there was a simple concept using a hash set. If you just traverse the linked list, if you find the same node again, that's a circle, that's a loop. But there was a different logic, again, using a slow and fast pointer. And to, again, this was pretty, it's kind of a question where you feel that it will work. Just move your slow and fast together and somewhere they'll meet. If they meet, it's a loop. But proving that mathematically can be tricky, and that's why I want you guys to understand this part also, where we mathematically figured out why they will meet. Okay. And then we discussed the pseudocode. Then the third question, very interesting question. If a loop exists in a linked list, find the starting point of the loop. Again, slow and fast come into the picture. We use it to figure out whether a loop exists or not. And then to figure out the starting point of the loop, we did a lot of mathematics that day to understand how this solution works. So go through this part. Okay, this is again one of those questions like the deep clone question. If you know, you know. If you don't know, you don't know. So again, make a note of this question, that before interview I will revise this question once. It's gonna benefit you if you just remember the solution for this question and the mathematical proof of why that's working. All right, that was this one. And then the last question was, given two sorted linked lists, merge them into a single sorted linked list. Now this concept is very important. Why? Because merge sort in linked list is pretty advantageous. Why? Because merge sort gives us a O of n space complexity when done with arrays, but merge sort gives us a O of log n space complexity when done with linked list. Okay, and you understand that because of this question, when I can merge two sorted list into a single sorted list without using extra space. You have to understand this problem. This has high chances of coming in an interview. And if we know that concept, then we did merge sort. The time complexity remains same, but the space complexity is reduced. And that's it. That's the second class. Then we went on to the third class of linked list. Where is it? Yep. So yeah, the third class of linked list. The first question was, check if a given list is palindrome. Now, palindrome checking in a string is easy because I can traverse in both directions using two pointers. You can figure it out. But in a linked list, singly linked list, it's tricky. Okay, so there it's tricky but still solvable. We figured out a solution that okay, we'll go to the middle, we'll break it into two parts, and then I'll reverse the second, either the first part or the second linked list, and then I'll just compare the two linked list. So works. It's a good problem solving question. Again, a good question. Do check it out. Then this was an interesting question. Again, very tricky. You need to make a note of this question as well. Find the length of the longest odd length palindromic list in a given linked list. Now again, we have done such a question with strings. We use the expansion concept. We take middle points and then we try to expand in both directions. Now this is not possible in a singly linked list because you can't traverse in both directions. So we use a brilliant hack. We keep on reversing the linked list as we go forward. So somehow, let's say if I'm trying out this to be the middle point, then these two links have to be reversed so that I can progress in this direction as well as this direction. Okay, do go through this problem, extremely important. And you can even do this for an even length palindrome to figure out the longest even length palindrome in your linked list. Next question, given a actually the next part was trying to understand the intuition of a doubly linked list. We did two questions where we understood that okay, if we had a doubly linked list, it would have been a beautiful world. The first question was, given a reference to a node deleted. Now we saw that okay, We can't really do this in O of 1. We need to do this in O of n because yes, I've been given a reference, but I somehow need to traverse to reach the node before that reference. Okay. Similarly, given a reference to a node, insert a new node. Again, the same problem arises. Because I can't traverse back from this current, I need to give it a full traversal, reach the node before current, and this becomes a O of n algorithm. Both these questions teach us that okay, linked list is awesome, but there are some restrictions, and that's why a doubly linked list was introduced. A linked list which has a node which has a previous reference as well. So you can traverse back, you can traverse forward. The node structure changes. Now we have a node prev2. This is how a doubly linked list looks like. The questions in doubly linked list are, I would say, twice as tricky, just for the reason that we need to handle 2 pointers now. In linked list we have edge cases, so in doubly linked list you have to be double focused to figure out the edge cases and work it out with both the pointers correctly in place. Then we solve the above 2 questions that we discussed, that okay, with a doubly linked list we can easily solve it, get done with it. And now a supremely important question, again make a note of it, you have to revise it before you go for an interview. How a LRU cache can be implemented using a doubly linked list. First of all, we understood what is a LRU cache. Do go through that. And then we understood the intuition, and we actually did a big dry run to understand how a doubly linked list can help us implement this cache system. And actually we need a doubly linked list and also a hash map, and it was a very beautiful solution, a very good problem solving solution, how using a DLL and a hash map you can implement LRU cache. Do go through this question. And that's it. That's all we did. That's the revision of linked list for you.